Hi, my name is Johan, and I'm on a mission to redefine what's possible in paragliding simulation. I've been working on Glide for about a year now, and in this video I will quickly touch on the graphics and rendering technology, the atmospheric and weather simulation, and the glider simulation. Glide is set in the stunning Swiss Alps, and the rendering technology will allow us to experience this in all of its glory. From rugged mountain peaks to vast forests and amazing lakes. The terrain is draped in stunning aerial photography. Every single building in the country is included. The atmosphere and fog lights up under a dynamic sky, and the vegetation rendering is some of the highest in computer games. All of this would make for pretty boring flying if we didn't have a live atmosphere to play with. To do that, I wrote a weather simulator that solves the atmosphere in real time on a 10-meter grid scale. This allows us to see how orographic clouds form in real time as moist air is pushed up a mountainside. But the true scope of a detailed atmospheric simulation can be seen here as we watch a sped-up animation of a thermal rising over a 10-minute period. It is clear how the air cools as it rises and starts to slow its speed of ascent. In this example, it was colored with smoke to make it more visible. When we zoom out and color it red, you can also see the clouds that start to form as that moist air cools down. This brings us back to the QT charts. Here you can see that as that air gets pushed up the mountain slope, the temperature starts to fall and the humidity increases in the moments before clouds form. We can also use a mouse to set the temperature, humidity, wind direction and wind speed directly on the QT chart. This way you can set up any condition that you would like to experiment with. And that brings us to the gliding simulation. The glider itself is a complex string and cloth simulation that runs at 1000 Hz and simulates the way that it deforms under aerodynamic forces and the weight shifting. This means that nothing is scripted or pre-programmed in the simulation. All of the movement of the glider comes from the changes in aerodynamics as the wing changes its shape and the air flows differently over it. This leaves us with a very unique simulator, where big ears can form by simply pulling on the outer A-lines, causing the air pressure on the intakes to drop and the wingtips to collapse. And this is where I need your help. Glide gives us a unique opportunity to redefine the way that we look at paragliding simulation. But simulating these wings from first principles with aerodynamics is only possible if I can start with high quality data. The amazing design decisions that you made, tweaking of line lengths, choosing aerodynamic shapes, different stiffnesses, different internal struts, is what gives these wings their amazing characteristics and capabilities. And without that same level of detail and quality going into the simulator, it's impossible to simulate these wings with any degree of accuracy. This is a great opportunity to push the boundaries of paragliding simulation, and I look forward to hearing from you.